Hello everyone, this is lesson S2, Planets of the Solar System for remote learning. So let's get started on here. First of all, you've kind of gone through that movie on the entire universe really. And so we're now coming back into our own local solar system, meaning around the sun. Now the inner planets, there are 4 inner planets, and they are Mercury, Venus, Earth, and Mars. Now the inner planets mean those that are closest to the sun. Now, if you remember from your diagrams, you had the sun, you had Mercury, Venus, Earth, Mars, and then you had all these different asteroids. Then you had Jupiter, Saturn, Uranus, and Neptune. And so another way to look at the inner planets is just they're in the inside of that asteroid belt. Okay, so that means the outer planets are going to be Jupiter, Saturn, Uranus, and Neptune. And these are furthest from the sun. Okay, so next question, we're asked to identify what the gaseous planets are. Well, the gaseous planets do just happen to be in our solar system: Jupiter, Saturn, Uranus, and Neptune. Which means that these 4 planets are mostly made of gas. So they will have no true surface on them, simply because of their composition. The terrestrial planets happen to be Mercury, Venus, Earth, and Mars. Terrestrial means that they are solid or have a true surface. So maybe you're familiar with the old hymn, Crown Him Lord of All, where we talk about how we're on this terrestrial ball. And really that's just saying is that Earth is a terrestrial ball. It is a solid surface sphere. So identifying the dwarf planets, there are in fact 5 dwarf planets in our major ones in our solar system. There are many others that have been discovered and found, but typically we say these are the major 5. The first 5 identified, and so we usually just go with them: Eris, Pluto, Haumea, Makemake, and Ceres. Now, Ceres is actually in the asteroid belt. So it's located between Mars and Jupiter. And these 4 are beyond Neptune. Usually, anyway. Pluto kind of comes in and out a little bit. It has a much more elliptical orbit. So what makes a dwarf planet different than a regular planet? Well, essentially, planets are rounded by their own gravity. and they orbit a star. And in this case, dwarf planets both do this. But a planet will clear its orbital path. Dwarf planets do not do this. So, as a dwarf planet is moving around, there could be other things in and around, and they're not big enough that as they move through, that these things wind up all getting cleared in and around the path. Thus, things like the asteroid belt or other dwarf planets. The reason for this change, and why Pluto essentially got demoted, shall we say, is because we used to have the 9 planets, but then all of a sudden, Ceres, Haumea, Makemake, Ceres, all these other dwarf planets started getting discovered, and instead of saying that we've got 50, 60, 70, 80 planets in our solar system, it kind of came down to a point where we had to say, okay, is this actually what we call something else? Now, on the next page, which really is using the things from page 412 to 415, you're going to find a couple of things. The first one's the ones that are smaller than Earth are all inner planets. The ones that are larger than Earth are all outer planets. But you're also going to find that the warmest planet is Venus. And this is mostly due to the greenhouse effect. Even though Mercury is closest to the Sun, Venus has lots of greenhouse gases and actually causes that planet to warm up a lot more than Mercury. Most of the energy just bounces right off of Mercury because it has very little atmosphere. So, grade 9. The next page is filling this chart out with the data cards from page 412 to 415 from your textbook. You'll notice Earth is not on here because, well, it is Earth-sized, and we know a lot about Earth from just living on this planet. Right, so this is a comparison of other planets within our solar system. One other interesting fact that can be from the textbook, but it doesn't have to be. This can also be from Googling or whatever, right? You can choose this. You're going to complete these charts and you are going to submit it in. I do suggest that you actually print it off and scan or take a photo, because one of the things in your unit book, and we're going to have to modify this assignment, is the modeling of the solar system to scale. Now, this is an assignment that we've modified. You're still going to need 6 meters of length in terms of space, so this is going to need to be done in a hallway. You're going to send a photo of your final result as well as an attachment of this. Right, so with your S2, you're going to need to be handing in the planet charts, right? The model chart, this one, and a photo of your model. I lost control of my pen there. Okay. So you'll notice that this is different than your book, so you are going to need to use what we've got on Teams for this, but you're going to complete this chart, and that's worth 2 marks. You're then going to need to actually lay out, so you're going to have all this space, let's say on some sort of hallway or something. You're going to put, let's say, a bowl, and you're going to label it sun. And then you're going to have to put objects for the other 8 planets and label them. Okay, you're going to need to do it to accurate distances as laid out within the scale distance here, right, this one. You're not going to need to worry about the diameter of the objects. Okay. So you're not going to have to worry about the scale diameters of these things. You're going to be dealing with distances that are too small. So in other words, Mercury, if you've got something, let's say the sun at 14 centimeters, Mercury on the same scale is half a centimeter, or actually not half a centimeter, half a millimeter in size. And for us to try to get that in a photo is just going to be impossible. And it should also be noted that the planets are actually 100 times larger than what they would be in terms of the actual scale distance anyway, so it doesn't really matter. The reason why we're doing the scale distance is just so that we've got this in here, so you can kind of see comparison of different sizes of objects. So that's the assignment. 3 things you're going to need to include in your submission with this lesson. 1, the planet charts, that's the previous page. 2, the model charts, that's this thing. And 3, a photo of the actual model that you put together. If you have any questions, please let me know. Thanks for watching.